Hey guys, what's happening? It's Mr. Gagnon. We're going to be taking a look today at gravitation. And again, you want to have your video set at 1.25 speed or higher. Google tends to slow down my voice. So this unit, we're gonna get you guys going with gravitation, and then we're going to look a little bit at other forces, and we're going to first of all realize that it's been well known since ancient times that the Earth is a sphere, and that objects that are near the surface tend to and always fall down. So Newton connected the idea that objects like apples fall toward the center of the Earth with the idea that the moon orbits around the Earth. It's also falling toward the center of the Earth. The moon just stays in a circular motion since it has a velocity perpendicular to the acceleration. So, I'm going to give you guys a little bit of information on gravity here. Gravity is a force. Well, let's see. Okay, a lot of people going through and say that gravity is a force, but in reality, gravity is an acceleration that which produces a force on objects. So if we say the force of gravity, it's okay, but in reality, it's an acceleration that produces a force on objects. So the cool thing about gravity is the fact that we know how to measure it, we know how it reacts, but we really don't know where the heck it came from, or what it is a part of. And I'm just going to get into a little bit of the modern physics behind gravity. What we think of as gravity is we think of an invisible force. And I'm just going to draw a picture of something that bends a fabric. So here's believe it or not, this is what's called space-time. Space-time. And we if we call space-time a fabric like this, then any object that has any mass will actually push down on space-time and cause a dip in space-time. So just look at what happens when I take a small object. We'll look at circular objects, and I put it really far away from this. Okay, let's say out here. Is this still affected by this? The answer is yes. But as I get closer, this little guy here is affected by this more and more and more until we get really, really close. And when we get really, really close to the mass that's sitting in space-time, we begin getting what the gravitational field is of this object here. Okay, and this could be a planet or a star or you. The fact about gravity is that gravity always exists. Okay, so gravity always exists. And that's a cool thing, because if I look at gravity, I really only feel the majority of gravity from the Earth, because it's what's pulling me down on the Earth. But in reality, gravity actually always exists. So my body is an object that feels gravity from the Earth, but is also pulled on by other large objects, such as houses, tables, cars, the sun really far away, the moon really far away. But we don't feel that because the forces are really negligible, but they don't disappear. And here's a little diagram to show you what gravity is really affected by. Okay, so we're going to call this M1. Okay, we'll call that a like a planet or something. And then there's the center of that, and between the centers of that that mass, we'll call this M2, and we'll call this R. Okay, so here's M1, M2, here's R, the distance between the centers of masses of these objects. So if I draw in another one, okay, we'll call this M1, M2. Okay, which one has more gravity here? Well, the one that's closer. So as the R goes down, the gravity increases. Now, I'm going to hit you guys up with a formula which is going to describe the relationship between two masses and their distance apart. And you can calculate the gravity of the objects. Okay, so with that, I'm going to give you guys what the force of gravity is affected on by two objects. Okay, so look, here's F, which is force, equals, well, leave some space here. Okay, it has something to do with the masses that we're looking at. Okay, the force of gravity is equivalent to the multiplication of these two masses divided by the radius, here's the radius, squared. So a really simple equation to describe the force of gravity felt on either of these masses on each other. And again, this force is measured in apples or newtons. And so, but now if I go and I just solve this for just the numbers here, this force is way, way, way too big. Okay, so it doesn't work out too well that way. So what we have is something that's called big G here. So it's big G times all of this stuff here. Okay, so big G is a constant. It's called the gravitational constant. And all you can think of it as is a number to make these numbers smaller. So I'm going to give you guys that number here, and I'll give you the units. The gravitational constant is 6.67 times 10 to the negative 11th. I'll give you the units. They are crazy units, so don't stress it too much. Okay, so the unit here for gravity is a Newton meter squared over a kilogram squared. No stress, just use that as a unit. So 6.67 times 10 to the negative 11th. Notice, that's a tiny number. And that indicates that gravity is a very weak force. So yeah, I said it. Gravity is a weak force. Very, very weak. And we're going to be looking at other forces, and you're going to realize that this G number really diminishes the size of the force felt on two objects. So I'm going to end the video there. We're at about 9 minutes. I'm going to put it into your the unit. Again, if you have any trouble, please feel free to contact me through email, and then we could set up a Google Meet if you need to. And yeah, let's call that a wrap for the first unit, for the first section here.